Welcome to a presentation brought to you by the American Wood Council. Thank you for your participation in our webinar today. This webinar is intended to provide general information only and does not constitute professional or engineering advice. Please note that this webinar is being recorded, and by remaining a participant, you automatically consent to such recordings. If you do not consent to being recorded, please disconnect from the session. This presentation is worth 1 LU/HSW with the AIA and 0.1 credits with the ICC. To receive credit for the course, you must attend this webinar for a minimum of 50 minutes. At the end of 50 minutes, you will see your certificate appear on your webinar console. Your certificate will also be uploaded into your learner profile on learn.awc.org, provided you registered for today's webinar with the same email address as your account profile. At the end of today's session, our presenter will have a live Q&A with the audience. Please input your questions into the Q&A panel throughout the session. And now, for today's presentation.
Good afternoon. My name is Ed Lisinski, and I'm the Midwest Regional Manager for the American Wood Council. Today, our webinar will focus on deck codes in the 2021 IRC, and especially some of the changes from the 2018 IRC. And here's the course description you may have read when you signed up for the class. This presentation introduces basic design and construction methods for single-story residential wood decks, focusing on the significant changes to the 2021 International Residential Code, or the IRC. The vertical and lateral load paths of conventional residential decks, as well as other general information about decks, is included. Specific design guidance includes convenient span tables for joists and beams, and tables of post sizing limitations and connection methods. In addition to all that, I will also mention a few places where there is a change to the 2024 IRC as well. And here are the learning objectives for today. Upon completion, you should be able to identify vertical and lateral load paths of conventional residential decks, identify minimum footing sizes and materials used in the IRC, determine appropriate beams and joist span lengths using the IRC provisions, and determine lateral connection options for the deck to existing dwellings based on the IRC requirements. Before we jump into the code provisions for decks, it's worth mentioning that the 2021 IRC references the 2018 National Design Specification for Wood Construction, more commonly known as the NDS. If you aren't familiar with the NDS, it's the standard that gives you the design equations for almost all types of wood structural members in the code. In addition to the NDS, there is an NDS supplement, which gives you many of the values that you use in the equations found in the NDS. The supplement provides you with section properties and species and design values for a variety of different woods. I will also note that if you're on the 2024 IRC or the 2024 IBC, they both reference the 2024 NDS. But again, the 2021 IRC references the 2018 NDS. I will also make a brief mention of the DCA 6 document from AWC. That is our prescriptive deck design guideline. While it's not referenced in the IRC, many jurisdictions or states adopt it directly as an accepted method for code compliance, or will accept it through an alternative design. You can view both of these documents for free on our website, which is awc.org. All right, we have a lot to go through, so let's get started. We're going to start off by reviewing some general code requirements. Our 1027 in the IRC tells you that a dwelling built under a certain code edition can remain in place without change. As long as you don't mess with your house, it can stay exactly as it is because it was approved under the code that was in effect at that time. Our 1027.1 goes on to specify that if you do something to your house, what you touch shall comply with the current code for a new structure, but the rest of the house can still remain as it is. However, and this language has been modified into the 2021 IRC a little bit, however, the alteration, addition, or repair cannot make the existing structure less compliant with the code. A residential deck could be considered an addition or an alteration to the house, depending on the size, configuration, and local ordinances. Let's take a look at an example of that. Say this is an existing house, and the homeowner wants to put a deck off the patio doors where the existing wood guard is in the picture. That's on the second floor above grade on the wall on the right. If they just add a deck there that comes out maybe 5 feet from the house, they shouldn't have a problem. The deck would meet the current code and the rest of the house can remain as it is, or as it was, approved under the code under which it was built. But if they want to do a deck and have a stair that comes down to grade, and that stair comes to the corner of the house near the garbage cans, they may have some issues. The stair could possibly block the egress door on the lower level, that patio door there, which means that if that was a required egress door, the existing house may now be less compliant with the code because the stairs are blocking it. The stairs may need to be relocated, or the egress door may need to be moved to another code-compliant location. Just a reminder that if you have newer products on a deck, always be checking for manufacturer's installation instructions. We will touch on this throughout the presentation, but for wood composite or plastic composite materials, you will always need a manufacturer's installation instructions. Same thing with many of the proprietary prefabricated connectors that we use on decks. Some decks are exempt from permit requirements in the code, as you can see here in R105.2. Many decks are provided with a separate foundation system to support vertical loads, yet are connected via a ledger as a means to resist lateral loads. In these instances, the deck would not qualify for this exception because it is attached to the house. The most difficult thing to determine for this exception is which door on a dwelling is functioning as the egress door required in R311.4, and verifying that it is not the one accessing the deck in question. In the event that a deck permit is not required, either through this exception or through a local ordinance, this section still requires all construction to be performed in a manner complying with the code, and compliance can still be enforced by the building official. Considering that so many permit requirements vary based on local ordinances, contractors should contact the building department for clarification of the permitting provisions as adopted or amended, as well as any other local ordinances. If the opportunity arises to bid a job using decking that the homeowner salvaged from another site, or even from his existing deck, approval is required first. Once the decking is removed from a deck, it becomes used material and may now be required to meet any standards that would exist for a new installation, even if it's from the same property. Installing new decking on an existing deck frame would not force the frame to comply with this particular section. It's a structure, not a material. It would, however, be required to comply as an altered structure. If the frame were to be dismantled for reuse, you would then have used materials. Often a building official will visit a site to approve used materials prior to permit approval and issuance. While decking and framing reuse may draw the most attention, reuse of appliances and devices such as low voltage lights, hot tubs, fireplaces, and other such amenities may also be regulated under this section. So there's 1,000 paths to code compliance. Many residential decks use some sort of alternative methods and materials. Let's break this section down a little bit. I should note that this applies to any section of the IRC and not just decks. The first sentence says that just because a design, a method of construction, or a material is not prescribed in the IRC, that doesn't mean it's prohibited. On a deck, new products are being designed and approved every day. The second sentence gives you, the building official, the authority to approve these alternatives. The third and fourth sentences give some background on what a building official will look for. The alternative design or material should meet the intent of the code provision and shall not make the structure less safe than the code. And then to wrap it up, if the building official does not agree with an alternative and does not approve it, they have to respond in writing with the reason why it was not approved. I mentioned this earlier, but the DCA 6 document is a prescriptive residential wood deck construction guide. Approval for someone to use this guide as opposed to the IRC would need to be approved through R10411 for an alternative means of materials, unless there is an ordinance or other rule that would allow it without that process. Technology is always advancing faster than the codes. Often products and materials are too new to be included in your adopted code version. When this happens, building officials should rely on evaluation service reports to determine code acceptance. Be sure to verify that the ESR is current and that the product is approved for use in the code version that you have adopted. All right, moving on from the administrative provisions, let's talk briefly about loads that act on a deck. A new sentence was added to section R507.1 in the 2021 IRC. It reads, decks shall be designed for the live load requirements of R301.5 or the ground snow requirements indicated in table R301.2, whichever is greater. Now also listed in table R301.5 are other loads that act on a structure in the code. Loads in this table which are important for decks are loads for guards, loads for guard fill-in components, loads for handrails, and loads for stairs. Keep in mind, some of these loads are a uniform load, some of them are a concentrated load, and some of them have provisions for both. Also keep in mind that table R301.5 only covers gravity live loads. There is no minimum lateral live load provided in the IRC, and that's why there's often side sway concerns with decks. We'll talk about that more coming up. Gravity loads are pretty easy to understand. Everywhere you stand or have a load on the deck, that load needs to be transferred to the ground through a footing. At that point, the ground resists the load to balance it out. If you think about standing on the center of a deck, your load will go from the deck boards you're standing on and be transferred to the floor joists supporting those deck boards. The loads on the joists will go to the beam and to the ledger board through hangers or through direct bearing. The load on a beam will be divided between two posts, and the posts will transfer that load to the footings and into the ground. Lateral loads are in the horizontal direction. These can come from wind, seismic, or side sway from people moving on the deck. I just mentioned side sway a couple slides ago. Typically, there's not much surface area for wind, but if there are solid guards, this could be more of a factor. Also, there is not much weight or mass for a seismic to be a great concern on a deck either. Most of the concern with lateral loads on a deck come in the form of side sway from occupants moving on it. Lateral loads acting to the left or right of the screen are not a great concern if the deck is built to code, because the deck will be connected to the house wall, which is braced. More concern comes from lateral loads perpendicular to the screen or parallel to the house wall, where there is no hard structure to resist the lateral loads. They all have to be transferred to the ground by the stiffness of the deck structure itself. Bracing, connections, embedment of the posts into the ground, or installing deck boards diagonally can contribute to reducing and resisting those lateral loads. All right, let's jump into the actual deck section, R507. Here's a typical standard deck and a good example of what we'll be talking about from here on out. We start off with the administrative section of the deck code. So R507.1 gives you the basic scope of the chapter. You'll notice that this chapter only covers wood decks. If someone wants to build a deck out of steel studs or other materials, they will need to go through an engineered design in Chapter 3 and then other material requirements. The 2021 IRC added in live load and snow load provisions into the scope. The live load has been referenced in another section of the code, referenced in another section of the code, but it was relocated to here and snow loads were added in. Remember, when designing a deck, you have to take the higher gravity load between the live load and the snow load. If you want to design a deck that is outside of the scope of R507.1 or exceeds the limits placed on a deck in other places of this section, that deck would need to be designed through engineering. This could be due to the size, shape, materials used, or a number of other factors. Section R507.2 is the materials section of the code. All information on materials used in R507 can be found here. There's information on wood, plastic composites, fasteners, flashing, and alternative materials. One change to this section in the 2021 IRC was to plastic composite decking. References to plastic composite decking throughout the section were referred back to this section, R507.2.2 for the most part. This section basically refers the code user to the manufacturer's installation instructions for the plastic composite material to make sure it's being installed and used correctly. We talked earlier about the importance of those manufacturers' installation instructions being on the job site, as well as ES reports for the materials. The only real requirements besides that are that the plastic composite material needs to be labeled, have a flame spread rating of less than 200, and the material standards are also provided in the code. But of course, the most common material on decks is still wood. Wood materials are covered by R507.2.1. All sawn wood used is required to be number 2 grade or better, and is required to be either preservative treated or naturally durable. There are some exceptions to this that we'll take a quick look at. Code is going to refer you back to section R317 for protection from decay. All wood, not just wood on decks, needs to be protected from decay anytime it will be exposed to moisture for an extended period of time. And section R317 gives a list of locations and situations where this will happen. I will note that in the 2024 IRC, this section moves to R304 in case you're trying to find it in the latest codes. One of those locations that will be relevant to this presentation is option number 8. This states that structural supports of balconies, porches, and similar appurtenances need to be protected unless they have adequate protection from a roof or covering that will prevent the wood from being wet. When you consider wind-driven rain or snow, that would have to be a significant roof or covering to adequately protect the deck or porch, especially down at the deck level. To further clarify this section, the 2024 IRC adds the word decks to the list of structures in the beginning of the code text. There is a geographical exception to this section in the code, or geographical exception. If you live in an area where decay is not a problem due to the climatic conditions of your region, the building official can exempt the requirements for preservative treated or naturally durable wood. There's also a reference to for protection from termites in accordance with R318. In the 2024 IRC, this section was moved to R305. Table R301.2 will provide locations where wood needs to be protected from termites, but if you have preservative treated wood in accordance with R317 or wood that is naturally termite resistant, you will meet that requirement. Again, you have two options to protect against decay and termites. The more common method is through preservative treatment of the wood used. R317.1 will require compliance with AWPA's U1 standard. Anytime you have cut ends or drilled or notched wood, you are required to make sure that the exposed portion of the wood is protected in accordance with the AWPA M4 standard. If you have structural wood members that will be in direct contact with the ground or embedded in concrete, those will be required to be protected to a higher standard. They will need to be rated for ground contact exposure. Let's take a look at sawn lumber quality marks to see where you can find that information. Any preservative treated wood is required to have a quality mark in compliance with R317.2. Those quality marks will have a ton of good information for the builder and the building official. The required quality marks on each piece of preservative treated lumber shall contain the following information. Number 1, the identification of the treating plant. Number 2, the type of preservative used. Number 3, the minimum preservative retention level. And 4, the end use for which the product was treated. Let's pause there and talk about retention levels. Some people may remember an old code requirement for retention levels requiring a 0.4 or higher for ground contact. However, the label will actually call out if it's approved for ground contact now. They found that different wood species can achieve the performance requirements for ground contact with a lower or higher retention level. So don't use that as a determining factor. If it's labeled for ground contact, it can be used in those situations no matter what retention level is being shown. Continuing on with the quality mark, number 5 on the screen is the standard to which the product was treated. Number 6, the identity of the approved inspection agency. And then number 7, the exposure condition. And that's all the required information that's on a quality mark. The other option to protect against decay and termites is to use naturally durable wood. There are specific wood species which are naturally durable against decay and ones that are naturally durable against termites. However, keep in mind that in order to use these species for protection, each piece of wood has to be cut out of the heartwood of the tree. That's the darker colored wood from the center of the tree. An occasional piece of sapwood can be included, but 90% of each side of the piece of wood has to be heartwood. Engineered wood can be used on decks. R507.2.1.1 refers the code user to R502 for more information on using appropriate engineered wood products. Keep in mind that many of these engineered wood products do not have a way to protect them against decay or termites, so be sure to select your products carefully and check any standards for providing protection. The most common use of engineered wood products on a deck is in a roof or a covering where it is protected from moisture accumulation. Fasteners, including nuts and washers for preservative treated wood, shall be of hot-dipped, zinc-coated galvanized steel, stainless steel, silicon bronze, or copper. Coating types and weights for connectors in contact with preservative-treated wood shall be in accordance with the connector manufacturer's recommendations. One thing to remember is not to mix and match types of fasteners that are in contact with each other or in contact with other metals. You can cause corrosion issues that will cause the fastener to fail prematurely. Now that we've covered the scope in R507.1 and the materials in 507.2, R507.3 starts to build the deck from the ground up. Deck footings shall be in compliance with this section. There are two exceptions for freestanding decks which do not require footings. Keep in mind that both of these options prevent the deck from being connected to the house. The 2021 IRC moves requirements for footing depth from section R403.1.4 into R507.3.2. A freestanding deck has to have a footing depth of 12 inches below grade. However, if the deck is connected to the house or another structure that has its footings at or below the frost depth, then the deck also has to have footings that are at or below the frost depth. There are significant changes, as we'll see, to all the tables in the deck code. In previous editions of the code, the tables would only give values for 40 pounds per square feet of live load. The tables have all been updated in the 2021 IRC to include not only the 40 pounds per square feet of live load, but also 50 pounds per square feet, 60 pounds per square feet, and 70 pounds per square feet of ground snow load. You may recall the change I mentioned earlier in R507.1, which requires a code user to select the higher gravity load value of the live load or the snow load, and that all the tables now reflect that. Another significant change to the footing table in table R507.3.1 for the 2021 IRC is the addition of a tributary area of 5 square feet. Table R507.3.1 prevents extrapolation beyond the limits of the table. You can interpolate between two tributary areas provided in the table. For example, if you wanted to find a footing size of 30 square feet, you can interpolate between 20 square feet and 40 square feet to find 30 square feet. However, you cannot extrapolate beyond the table. This created a situation where the smallest footing you could have was based on 20 square feet of tributary area in the 2018 and earlier IRC. New to the 2021 IRC, the 5 square feet tributary area values provide for smaller and more accurate sizing of posts which are not carrying very much load, and that's posts and footings. Keep in mind that this table can only be used with uniformly distributed loads. If you have point loads on the deck, you will have to determine footing sizes through engineering analysis. I mentioned tributary area a couple times on that last slide, but often people are confused by that term and how to determine it. So let's take a closer look at it here. We have a freestanding deck that's 20 feet by 12 feet with 6 posts, all evenly spaced. Let's determine the tributary area for the center post and the corner posts. Tributary area is the area that contributes to the loading on each post and from the post to the footing. You can find it by taking half of the distance from one post to the next in each direction. Multiplying those values together will give you the area of the deck that will contribute to the load on each post. So for the corner post, you can see that the three posts are spaced 10 feet apart left to right. That means that in that direction, 5 feet of the load will go to the corner post and 5 feet will go to the center post. In the up and down direction on the screen, the posts are spaced 12 feet apart, so 6 feet will go to each corner post. So in this example, the corner posts will have 5 feet of deck in one direction and 6 feet of the deck in the other direction, which will give you a tributary area of 5 feet times 6 feet, or 30 square feet. On the center post, the 6 foot distance is still the same, but now there's 5 feet of load coming in from the left and 5 feet of load coming in from the right, or 10 feet of total floor load in that direction. This will result in a tributary area of 6 feet times 10 feet, or 60 square feet. From here we can go into table R507.3.1 and find our footing sizes. Table R507.3.1 provides options for both square and round footing sizes. The example here only gives you the round footing diameter sizes. Section R507.4 covers deck posts. This section is relatively short and basically consists of this table shown and a requirement that deck posts be laterally restrained. The lateral restraint is either through a manufactured connector or by embedding the post into concrete that is at least 12 inches deep below grade. Table R507.4 was again expanded in the 2021 IRC to include 50 pounds per square feet, 60 pounds per square feet, and 70 pounds per square feet of ground snow load, in addition to the previously provided 40 pounds per square feet of live load. The table provides for a maximum post height based on the loading, species of the wood, size of the post, and the tributary area. Just like the footing table, you can interpolate between two values on the table, but you cannot extrapolate beyond the table. You may notice that the 5 square feet of tributary area that was added for footing sizes was not included in this table, so any post with a tributary area of less than 20 square feet would have to use the values provided at the 20 square foot column. Next up is deck beams, which are covered in R507.5. First, let's focus on sizing of the beams. We'll come back to the rest of this section in a little bit. As you are aware, the 2021 IRC added in tables for 50, 60, and 70 pounds per square feet of ground snow loads, in addition to the 40 pounds per square feet of live loads. You may notice a small change, but one that created a large impact in the 2021 IRC for deck beam sizing. The deck beam length is found in the table by using the loading, the wood species, the beam size, and a new term, effective joist span length. Previous versions of this table from the 2018 IRC and earlier would have included regular joist span length, but now the 2021 IRC changed this to effective joist span length. What does that mean? The beam table was previously designed to account for the worst case scenario of a joist at full span plus the longest permissible cantilever at the end of the joist. This meant that if the joist did not have a cantilever or a smaller cantilever than the maximum permitted, the beams would be sized very conservatively. This resulted in either larger beams or shorter beam spans than what was structurally necessary. This new concept of effective joist span was developed to account for those joists that have no cantilever or a shorter than permitted cantilever. Before we look at that closer, here's a quick reminder about beam span. In the IRC, the beam span is not the beam length and it's not the clear dimension. It's measured from the center of the post or the center of the bearing to the other center of the post or the center of the other bearing. The beam cantilever length, which is permitted to be used up to 1/4 of the beam span, is then measured from the center of the post or the bearing to the end of the beam. Now let's get back to this concept of effective joist span length. Again, beam tables had been sized to account for full cantilever in previous editions. Now, a beam that is only supporting joists with no cantilever or a shorter cantilever can be reduced in size or increased in span. Table R507.5, parent 5, gives an adjustment factor to be applied to the joist span length to find the effective joist span length. This adjustment factor gives a much more accurate size to the beams. Note that this uses actual joist length and actual cantilever length. I also want to note that if someone goes into the beam table and misses this requirement, the table will read exactly as it did in previous code editions. It would be the conservative beam sizes and spans that were always in the code. So if this is missed, you are no worse off than you always were in the code. But if you use this adjustment factor, you can get a more accurate and less conservative beam size or span. Let's see how this plays out in an example. Here's an example of effective joist span length and how it applies to a beam size or spacing. For example, a deck has a 2x8 southern yellow pine joists at 16 inches on center with a joist span of 8 feet and a 1 foot cantilever. The joists are bearing on a southern yellow pine double 2x10 beam. What is the maximum beam span with 40 pounds per square foot of live load? To determine the joist span factor, the C over J value is 1 over 8 or 0.125. A 1 foot cantilever divided by the 8 foot joist length. Therefore, you have a joist span factor of 0.84 according to table R507.5, parent 5. That joist span factor is multiplied by the actual joist span length to determine the effective joist span length. 8 foot joist span times 0.84 will give you 6.72 feet for an effective joist span length. Interpolating in table R507.5, parent 1, between 6 foot and 8 foot for the 6.72 foot will give you a maximum beam span of 9.85 or about 9 foot 10. If a designer misses the adjustment factor that can be applied and they go into the beam table with R507.5, parent 1 with just an 8 foot joist span, they will end up with a maximum beam span of 9 feet. So this is more conservative than what is actually needed. If this seems like a lot of work to you, many people agreed, and this concept was simplified for the 2024 IRC. But you'll have to wait for our presentation on the 2024 IRC Deck Code to learn a little bit more about that. All right, let's jump back into R507.5. Often beams on a deck are done with multiple plies. The code gives you requirements for how to connect those plies to make sure that they act as one beam as opposed to individual boards just sitting there next to each other. I mentioned this earlier, but beams are permitted to have a cantilever on each end up to 1/4 of the actual beam span. And remember that beam span is measured from the center of the post to the center of the post, or center of bearing to center of bearing. And finally, if you have a beam span or a beam that doesn't fit into one of the tables provided, you will have to use engineering analysis to determine that beam's size and span. Beams need direct bearing on a wood post, a metal connector, or on masonry or concrete. Beams are not permitted to be bolted to the side of a post. They need to have bearing underneath the beam. If you have a beam splice, that beam splice has to occur over a post. Figures R507.5.1 parent 1 and R507.5.1 parent 2 provide details on how a beam is required to be connected to a notched post. Also note that bolts are required to have washers under both the head and the bolt. R507.6 brings us to allowable joist spans. As I'm sure you're sick of hearing by now, the tables have been expanded out to include the 40 pounds per square foot live load that they've always had, plus the 50, 60, and 70 pounds per square feet of ground snow load. To find your joist span length, find the appropriate loading table, find your species, the joist size, the joist spacing, and that will give you the joist span length. There is nothing in this table about effective joist span length, so don't worry about that. This is actual joist span length. The effective joist span length is only used in the beam tables. You will also notice to the right of the table, on the right-hand side of the table, the maximum cantilever length is based on joist span. While the first part of the table gives you the maximum joist span, the cantilever section will give you the maximum cantilever based on the length of the joist that you actually have. As an example, if you follow the row for Southern Pine 2x8 joists, you will have them, and you have them at 16 inches on center. Your maximum joist span is 11 foot 10 inches. But if you only have 8 foot long joists, you can follow that row to the right and find 8 foot joist back span, and that will tell you that you can have a 2 foot maximum cantilever length. Similar to beams, when we talk about joist spans, we're going to use the center of bearing to center of bearing. Here's a common application of joists that are connected to a ledger board at the house with a joist hanger and are bearing directly over a 2-ply beam. The joist span length goes from the center of the joist hanger on the right to the center of the double beam on the left. Again, the joist span length is not the clear dimension, and it's not the overall joist length. The code provides examples of common joist configurations in figure R507.6 to illustrate how the joist span length is determined. You will see in each situation, it's the center of the bearing to the center of the bearing, whether that's a joist hanger or a beam. R507.6.1 gives requirements for deck joist bearing. Deck joists can bear on wood, metal, concrete, or masonry. Wood or metal connectors or hangers are the most common, and they require 1 1/2 inches of bearing. If a joist is bearing on a single-ply beam, a mechanical connector is required. Find a connector that's appropriate for use in that situation, and of course designed for use on the exterior. If a joist is framing into the side of a beam, a joist hanger is required for that connection. Again, make sure it's designed for exterior use. R507.6.1 goes on to talk about lateral support for joist ends. You don't want the joist to be able to twist or rotate when loaded. A common way to provide that support is to use joist hangers or blocking. When this method is provided, support is required for at least 60% of the depth of the joist. So if you have 2x10 joists, the joist hanger or blocking needs to provide support for at least 6 inches, which is 60% of that 10 inches, of the joist depth. Another common method for providing that lateral support is through a rim joist at the joist ends. In that case, the rim joist would be the same depth as the floor joist and are required to be fastened with 3 nails or screws on each joist end. All right, we started with the footings, we moved up to the posts, then the beams, then the joists, and now our 507.7 moves on to the deck boards. You will see that deck boards are required to be attached to each floor joist by at least 2 8-penny nails or 2 number 8 screws. You may also notice that plastic composite deck boards are required to meet our 507.2.2, which we discussed earlier. The maximum span for deck boards is based off of floor joist spacing, deck board sizing, if it's spanning 2 or multiple joists, and if you're running the deck boards perpendicular to the joist or diagonally. Keep in mind that diagonally in the code refers to 45 degrees from perpendicular. Our 507.8 will discuss vertical and lateral support of the deck. When you have a deck that is connected to a house, you need to have a good solid connection between them. If you have a deck that utilizes floor framing members from inside the house that cantilever out, you will have to check that for uplift forces on the underside of the deck. A high uplift load from wind on the outside could cause the floor joist to fail inside the house depending on loading factors. A structural analysis is needed for any deck constructed like that. Here's an example of what I'm talking about here. The floor joists from the deck are actually cantilevered floor joists from inside the house. So this will need structural analysis on that uplift. Jumping back to R507.8, when you can't have that strong connection to the house, then the deck is required to be self-supporting. This would typically result in a set of beams and posts close to the house. Here's an example of that. You can see the beams and posts near the exterior wall of the house, and the deck joists are cantilevered the rest of the way to the house. Just a quick note here, I mentioned very early on that the existing house can remain as is under the code under which it was built, until an addition or an alteration makes it less compliant with the code. Prior to this deck being installed, the windows on the left-hand side of the existing house were probably just normal windows. However, by installing this deck, you now have a walking surface very close to the bottom edge of the windows. So those windows will now be required to be replaced with tempered safety glazing if they didn't already have it. R507.9 will bring in requirements for support to the band joists of the house itself. This is not a band joist on the deck. Again, this is for attachment to the house when it's required by R507.8. The most common way to attach to the house is a ledger board attached to the band joist. The ledger board is one of the most critical elements in a deck. They are required to be number 2 grade or better and a minimum 2x8 size. Ledger boards cannot be loaded with concentrated loads, and they cannot be attached to veneers. They need to be attached to the band joist or other structural member of the house itself, unless of course they are freestanding decks. Here are some examples of attachment of a deck when you have a veneer on your house. You can remove some brick and install additional wood blocking or rim joist, as you see in the upper left-hand corner. You can lower the ledger to get to solid concrete or masonry, like on the upper right-hand corner picture. Or you can have other methods to attach the ledger to something else structurally. There are now proprietary fasteners on the market which will go through the veneer, maintaining proper air gaps, and attach the ledger to the rim joist or structure behind the veneer. But the bottom line is the veneer itself cannot be used for attachment of the ledger board. And again, keep in mind if you have any proprietary fasteners that you're using in that situation, that they need to be to follow the manufacturer's installation instructions and any ES reports. I mentioned this a couple slides ago, but R507.9.1.1 states that a ledger cannot support concentrated loads. If you have a beam or point load that needs support, as in a situation shown where you have a wraparound porch type deck, or the joist change direction, you have a couple of options. You could run the beam into the house structure so that it's being supported by the bottom plate or the foundation of the house. Another option is to add an additional post and footing near the corner and cantilever the beam back to the house. Either option would work, but again, do not use the ledger board to support a point load. The fastening schedule only accounts for uniformly distributed loads. The band joist on the house that's supporting the ledger board is required to be 2x nominal lumber or a 1-inch engineered rim board, and they need to have full bearing on a plate. It's a very important situation to be aware of if you have a house with floor joists, which often don't have a rim board. They often just have a ribbon strip of OSB. Make sure to plan out any potential future decks with your builder on a new house that may be designed this way. Also, if floor trusses are common in your area, be sure to check the existing plans or permits for a newer home prior to issuing a permit for a deck. They may have to add some structural members to support a ledger board or to build a self-supporting standalone deck. R507.9.1.3 gives you prescriptive tables for ledger board fastening utilizing 1/2-inch leg screws or bolts. Other proprietary solutions exist for ledger board connections, like I mentioned earlier, but be sure to check the manufacturer's installation instructions and/or the ES report for correct use, spacing, and location. And here is that ledger board attachment to the band joist table. As you can imagine, this table provides for different attachment requirements for 40 pounds per square foot of live load and 50, 60, and 70 pounds per square foot of ground snow loads. As with the other tables, you can interpolate between values, but you cannot extrapolate beyond the limits of the table. R507.9.1.3 parent 2 gives you the location of the bolts or lag screws for both the ledger and the band joist. Here's what that table looks like graphically as it relates to placement on the ledger board. This is figure 507.9.1.3, parent 1. And figure R507.9.1.3, parent 2 gives you the placement again, but as a cross section, so you can see how this applies to the band joist on the house. We talked earlier about lateral loads and how the code addresses lateral loads as they go perpendicular to the house wall, but really do not address them when they act parallel to the house wall. R507.9.2 is where we find those requirements for the lateral loads that act perpendicular to the house wall. The code will give you two different options. The first one is shown here, which is to use at least 2 tension devices per deck, one near each end, each capable of supporting 1,500 pounds. Here is that option shown graphically in the code. Keep in mind that this option will only work if you have sawn lumber floor joists. You cannot use this option if you have wood I-joists or trusses for your floor system, just because the tension device does not have that support structure to hold on to inside the dwelling. The second option is to install at least 4 750-pound tension devices. You may notice that both options will support a minimum of 3,000 pounds of lateral force on a deck, but again, that's only on lateral loads acting perpendicular to the house wall. And here is option 2 for a lateral connection, as shown in figure R507.9.2 parent 2 in the code. Here's the latest topic, or the last topic that we'll cover, which is guards. Prior to the 2021 IBC, the code user was referred to sections R301.5 and R312.1 for all requirements on guards. These are the same sections for any other guard on a house. The 2021 IRC still refers you there, but also brings in some other requirements that are specific to exterior decks in R507.10. R507.10.1 requires that guards have a continuous load path to the deck joists. The code provides 2 methods to provide that code path to the joists: guards attached to the side of the framing or guards attached to the top of the framing. If you attach the guards to the side of a joist or beam, you have to make sure to secure that joist or beam to prevent it from rotating. This is typically done through blocking. If you attach the guard on top of the framing, you will need to attach it to the joist, beam, or blocking that will then attach to the joist or the beam. R507.10.2 prevents you from notching a 4x4 post used as a guard post. R507.10.3 refers you back to R507.2.2 for plastic composite guards, and any other guard material you use needs to follow the manufacturer's installation instructions and, of course, any ES report in accordance with R507.10.4. I'm sure many of you are familiar with the requirements in R312.1 for guards. That section will cover things like when a guard is required, the height of a guard, and the size of openings permitted in a guard. One thing to keep in mind, especially for decks, a guard is required when the walking surface is more than 30 inches above the grade below, but that measurement is taken in any location within 36 inches of the edge of that walking surface. This can become critical on a deck with a sloped grade below. As you can see in the picture on the far right-hand side of the deck, the grade is over 30 inches. Even though the grade slopes up as it moves to the left, portions of that deck are within 36 inches horizontally of a 30-inch drop-off, and therefore they are required to have a guard. And that wraps it up. I will once again remind you that AWC also has our own prescriptive wood deck guide, the DCA6, which you can find on our website, awc.org. We also have a Spanish version available there. This document can be a great resource for a building official or a builder. And with that, I thank you for your time and attention, and we will move on to the live Q&A portion of the webinar.
All right, thank you so much, Ed, for that informative presentation. We have just a few minutes for questions, so let's get right to it. Our first question is, why is the live load requirement for IBC live load on decks greater than the IRC requirement, 60 PSF versus 40 PSF?
Yeah, thanks, Annie. Can you hear me?
I can.
All right, perfect. Yeah, and there were a lot of questions in there about loads, so I'll kind of address a bunch of these at once. Yeah, so a lot of questions about the 60 pounds per square foot versus the 40 pounds per square foot. So yeah, so keep in mind that we're dealing with the IRC right now, the residential code. Residential code just has 40 pounds per square foot in the code. A lot of people are referring back to the IBC, which talks about either 60 pounds per square foot or the 1.5 times the load that's on that the occupancy, the load of the occupancy that's being served by the deck, I should say, which would be 40 pounds, but then when you multiply it by 1.5, you get 60 pounds per square foot. That's also nobody mentioned it here in the Q&A, but that's also the same requirements that are in ASCE 7, which is where the IBC got that from. So, keep in mind, this presentation, everything that's in R507, we're just talking about, 1 and 2 family residential decks. So that's where the 40 pounds comes in. That's in table 301.5 in the code. So, that's sort of the difference between those. In the IBC, it does talk about 40 pounds for residential. This talks about 40 pounds for residential. But when you get to decks and porches and things in the IBC, there is that 1.5 times factor, just for that additional factor of safety for commercial uses. So that's sort of where that discrepancy kind of comes from. Somebody also talked about load combinations. Yeah, load combinations falls in, through engineering analysis, through the IBC. You're not going to see load combinations in the IRC. Now, again, the R507 is a prescriptive method of designing a deck. There's many times where maybe you have a material that doesn't match that. Maybe you've got a loading situation that doesn't match what you can do there. You have a hot tub on there with a high point load, and you have to go into engineering analysis. Yeah, that's where you can go into ASCE 7. You can bring in load combinations. You can do some things like that then when you're doing an actual engineering analysis on a deck. But if you are going through the prescriptive requirements that are in 507, you're just using those 40-pound live load or the 50, 60, 70-pound ground snow loads. A little bit of a variation on that. Somebody else also asked about guards and the loads on that. We had a portion of table 301.5 up there at one point. There's 2 requirements in there for guards. There's a 200-pound concentrated load on the top of the guard, and then there's also a 50-pound concentrated load on the infill portion of the guard. So, yeah, both of those are going to come into play. Again, the 200 pounds that's at the top of the guard on the both kind of working down and working its way out. But then the 50 pounds is on the infill components of the guard. So that's your spindles, or if you have a glass panel in there, cables, anything like that you're using to keep people from falling through the guard. So yeah, a lot of great questions on loads. There was also one I should mention too on sliding snow. If you are in a situation where you maybe have like an A-frame house where you've got a really high sliding snow potential. That would be something where you probably would not want to use the prescriptive requirements here in 507. That would you would want to go out and do some engineering analysis on that to make sure that that sliding snow is not going to do any harm to the deck boards or the joists or anything like that. So, yep.
Got it. Thank you. Our next question is, if you have a deck supported independently from a house for gravity loads, does a ladder load attachment, does this still require full frost depth footings on the deck?
Yeah, and so that kind of came up. There was some slides earlier on about taking your footings down to frost level. The code reads, anytime that you're attached to the house or another structure, I guess, that has footings down to the frost depth, that the deck also has to have footings down to the frost depth. So even if your loads are just supported through the deck itself or through the footings in the deck, and you're just sort of bracing it back to the house with the lateral bracing, to me at least, that's still attaching it to the house. You might want to talk to your building official in the area there, see if they agree. But the code does say, if you are attached to the house and that house has, footings down to the frost depth, that your deck would also have to have footings down to the frost depth. Some other variations on that. Some people asked about distance from the house if you have frost footings, and that's always a kind of a tricky situation there. Anywhere in the IRC, it's going to tell you that you can't put footings onto fill material. So you almost have to be far enough away so that you're not in fill, especially if you have a full basement or something there where they're excavating out next to the foundation. So depending on how new that house is, now if that house has been there for 100 years, I'm sure everything is settled there. You could probably just put that down to your normal frost depth. But if you're having posts and footings really close to a house, there's not a distance away. But if that had been recently excavated and that's all fill next to the foundation, you're actually probably going to have to take that footing all the way down almost to the basement level to where you get down to some virgin soil, so that you're not putting the footing onto fill. So there's not a distance in the code, but again, you've got some considerations. Maybe if you go a little bit farther away, you're not putting that on fill, so you can just go down to your normal frost depth. But if you are closer, you have to get down to some real good soil. Somebody also asked about stair footings. Yeah, stair footings. Those if the rest of the deck is under frost depth, those stair footings should also be at frost depth. And the reason for that, you don't want them to shift differently from each other. So if that house is on frost depth footings and the deck that you're attaching it to is not, that deck is going to move differently than the rest of the house will in freeze thaw cycles. Just like those stairs, you don't want those stairs to move differently from the deck during freeze thaw cycles, because you're going to start putting a lot of stress and strain on those connections. So either everything's kind of sitting up on top, riding above the frost level, or else it's all getting down below the frost level where it's staying together and staying put where it's at.
Great, thank you. I think we have time for one more question. So someone wants to know, does that mean carriage bolts are not allowed per code?
Yeah, we had a couple questions about carriage bolts. And the quick answer on that is really just that carriage bolts are really not utilized very much in the National Design Specification, which is a AWC document that kind of addresses how to design for wood connections and wood assemblies in the code. So carriage bolts aren't really addressed in there, which is why they're really not addressed in the IRC. So we actually do have a frequently asked question on that FAQ on our website, awc.org, if you want to go out there and learn a little bit more about it. But essentially, yeah, it's not in the prescriptive requirements. Now, you could go through an engineering analysis and use them that way, but yeah, through the straight prescriptive requirements, there would not be anything to use those on.
All right, great. Thank you so much. Ed, thank you so much. That's all the time that we have for today. So I want to thank you so much for sharing your expertise with us. And I really want to thank our audience today for joining us. We are going to have another webinar next month, Thursday, June 27th at 2 p.m. Eastern for next month's webinar, 2021 International Residential Code, Significant Changes, Part 1. So thank you again for joining this American Wood Council webinar. We'll see you next time. Have a great day.